In this video, I'm going to talk about combination circuits. If you have a series circuit like this one, we have two resistors and the total resistance or equivalent resistance R equals R1 plus R2, Req. The current flowing through the resistors would be the same. There is only one path for the electrons to flow through. So if the current flowing through the battery is, let's say, 2 amps, the same 2 amps current will be flowing through the first resistor and the second resistor. Now let's take a parallel circuit. Two resistors connected in parallel across the battery. The equation for equivalent resistance in this case is the inverse of Req. That is 1 over Req equals 1 over R1 plus 1 over R2. We have only two resistors, so 1 over R1 plus 1 over R2. This is R1 and this is R2. In this case, if the resistor values are different, then the current flowing through the resistors would be different, because let's say 2 amps current is flowing through the battery, and upon reaching this junction here, some electrons would flow through R2, some electrons would flow through R1. So let's say 0.5 amps is flowing through R2 and the remaining 1.5 amps is flowing through R1. So the current would be different, but the voltage across the parallel resistors would be the same. So this side of the of resistor R1 is connected directly to the positive terminal of the battery, and this side of R1 is directly connected to the negative terminal of the battery. So if battery is providing, let's say, 10 volt, the voltage across R1 would be the same, 10 volt. Same for R2 as well. This side of R2 is directly connected to the positive terminal of the battery, and this side of R2 is connected to the negative terminal of the battery. Since the battery is providing 10 volts, if you connect a voltmeter across R2, it will give you 10 volts. R1 is also 10 volts. So let's summarize. For a series circuit, current would be the same. And for a parallel circuit, voltage would be the same. What if we have a combination of series and parallel circuits? Like in this circuit, R1 and R2 are connected in series and R3 is connected in parallel across that combination. Or you could say R1 and R2 are in series and their combination is in parallel with R3. So how do you find the current flowing through the battery, or the total current in the circuit? Okay, so let's start with R1 and R2. They are in series, right? So the combination or the equivalent resistance of R1 and R2, that is R12, is equal to R1 plus R2. That is equal to 5 plus 10, 15 ohms. That means you can replace R1 and R2 and connect a single resistor of 15 ohms and the circuit would behave the same. Draw that. I'm going to replace R1 and R2 with a single resistor R12. We have R3 here, connected across a 10 volt battery. R12 is 15 and R3 is 10 ohms. Right? These two circuits are equal. Okay, so we replaced R1 and R2 with R12. Now R12 and R3 are parallel to each other. The equivalent resistance in this circuit is 1 over Req equals, we have R12 and R3 in parallel, so 1 over R12 plus 1 over R3. 1 over Req equals 1 over 15 plus 1 over 10. 1 over Req is so 1 over Req equals 5 by 30. Req equals 30 over 5, 6 ohms. So that means you can replace all these resistors with a single 6 ohm resistor. That is equivalent resistance in the circuit across the battery, and the circuit would behave the same. 6 ohm and a 10 volt battery. The question is, what is the current flowing through the battery? We can use Ohm's law. V equals IR. I equals V over R. We're finding the current through the battery, so the total resistance in the circuit, V over Req, is 10 over 6, 1.67 amps. Another one, we have 5 resistors in the circuit, a 2 ohm resistor, a 5 ohm resistor. They're connected in series, and they're connected to 10 ohm resistor and a 30 ohm resistor connected in parallel. Across a 100 volt battery. Let's call them R1, R2, R3, R4. R2 and R3 are connected in parallel. R2 parallel to R3, but their combination is in series with R1 and R4. So we're going to start with R2 and R3. We're going to solve, we're going to find the equivalent resistance of R2 and R3. 1 over, they're connected in parallel, so 1 over R23, there is the equivalent resistance of R2 and R3 is equal to 1 over R2 plus 1 over R3. So 1 over R23 equals R2 is 10 and R3 is 30. That is 4 by 30. That is 1 over R23. So R23 equals 30 over 4. 7.5 ohms. So we can replace R2 and R3 with a single resistor. We can replace them with a single resistor of 7.5 ohms. I'm going to draw the new circuit. This is R1. I'm replacing R2 and R3 with a single resistor R23, and we have R4 connected across a 100 volt battery. R1, R23 and R4 are connected in series, so they're equivalent resistance. That is Req is equal to R1 plus R23 plus R4. R1 is 2 ohms plus R23 is 7.5 ohms and R4 is 5 ohms. 14.5 ohms. That means we can replace all the resistors in the circuit with a single 14.5 ohm resistor across the battery, across the 100 volt battery, and the circuit would behave the same. So that's the equivalent resistance of the circuit. And to find the current, we can use Ohm's law. I equals V over R, or Req. That is 100 over 14.5, 6.89 amps.